Hi, my name is Trevor DeVries. I'm a professor and Canada Research Chair in the Department of Animal Biosciences at the University of Guelph. And today I have the pleasure of speaking on the topic of precision feeding and health management in dairy cows as part of this Dairy at Guelph Virtual Showcase 2020. What I hope to do is share with you some of the recent research results that my group's been involved with as it relates to this topic area. When we think of precision dairy management, a lot of things might come to mind. A classic definition of this is automation using sensor-based management tools that define animal needs and robotic equipment that automatically delivers individual animal management applications. And while there's a lot going on in that definition, there's a couple key things to keep in mind. And that includes the use of automation or technology and the individual animal application of those technologies. One of the reasons that we see and hear a lot of interest in the idea of precision management within the dairy industry is the fact that we have a lot of automation or technologies that are being adopted within the industry, primarily to automate management tasks like milking, like feeding, cleaning, reproduction, as well as health management. Specifically, one of the interests of my group has been looking at automated or robotic milking in relationship to precision feeding and health management. One of the reasons for that is the fact that we have a high adoption of robotic milking within the dairy industry currently, specifically here in Canada as well as worldwide. One of the advantages of robotic milking from a variety of perspectives is our greater ability to manage cows at the individual level. And so that provides great opportunity when it comes to thinking of precision feeding and precision health management strategies and opportunities. We've been looking at this from a variety of different angles, and here's just a few questions that I'd like to cover in this short presentation with you here today, specifically whether or not we can meet the nutritional requirements of cows throughout their lactation, can we maintain precision and individualized feeding approaches, and are we able to earlier identify, say, illness in dairy cows? And so first, the question of being able to meet the nutritional needs of cows throughout lactation. Now, that's one of the opportunities that we have in robotic milking is the fact that cows go to the robotic milker and receive additional nutritional supplementation through feed that's provided in the robot, in addition to the feed that they consume at the feed bunk. And that feed provided in the robot is first and foremost there to attract them to the robot so that those cows will milk voluntarily, but also so that we can potentially meet their individual nutrient needs. Now, again, we have lots of opportunities here. One of the specific questions that we've been looking at is whether or not we can meet the nutrition requirements of cows in early lactation, where we have in previous research demonstrated a need whereby we see, say, increased incidences of ketosis or negative energy balance in cows in early lactation that are milked in robots as a result of energy deficit. And so one of the questions we've been looking at is whether or not we can get extra supplemental energy into those higher producing cows in order to meet those needs. And just an example of that research, this is a study that was published this year, done by one of my grad students, Sydney Moore, looking at whether or not the supplementation of a liquid-based feed, a molasses-based liquid feed, which would be high in sugar or a gluconeogenic precursor for that cow in terms of energy, in order to reduce the risk of negative energy balance in early lactation. And that's exactly what Sydney demonstrated in this research, in that those cows that were supplemented with extra energy in the form of molasses in early lactation demonstrated not only overall better energy balance as indicated by blood markers, but had reduced number of reoccurring positive subclinical ketosis tests based on blood beta-hydroxybutyrate measurements, suggesting that we have some opportunity there then to increase our precision in terms of meeting those requirements at various stages of lactation. Another question that we've been looking at or trying to address in our research is whether or not we can maintain precision in those individualized feeding approaches. And the reason we ask this question is the fact that variation may actually be a problem. And this goes directly against the idea behind precision feeding. And so the idea behind precision feeding is that we don't only hit the target, so that's our accuracy, but that we hit that target in the same spot every day. And that becomes real precision feeding. And that's something that we've noticed can be problematic when we're trying to achieve individualized feeding approaches in robotic milking systems. And so some work by one of my other graduate students, Anna Schwenke, demonstrated that when we provide cows with more feed in the robot, so a higher level of concentrate in the robot and a lower density ration at the feed bunk, as demonstrated in the blue lines here, when we looked at the day-to-day variation in concentrate intake at the robot, so the middle of the slide here, we see higher variability, so higher standard deviation in intake representing day-to-day variation in those cows that are fed a higher level of feed in the robot. And so if we're trying to achieve precision from an individualized management standpoint for individual cows, but we're creating that increased variability, that's not very precise at the end of the day. And so we're trying to now figure out what may be contributing to that variability and how we can then minimize the risk of that variability from manifesting itself. And so one of the questions that we've been trying to answer in subsequent research done by Anna is actually what may be contributing to that variation. And one of the hypotheses is individuality in cow behavior, or cow personality, so to speak. And so what Anna's been doing is applying personality tests to dairy cows and then looking at how they respond within a robotic milking environment and whether or not that personality of those cows has an impact on their milking behavior and production outcomes. And definitely Anna's made some strides here and found some very interesting results. One of the first things that she demonstrated was that cows who are more fearful of a novel object, and you can see here, this is how we do this. We introduce cows into a novel arena where we may introduce, say, a novel object like this tote here that you see, and we look at how that cow responds to that novel object. Now, in this case here, this is a clear indication of a cow that's not very fearful of this novel object. But by specifically looking at those cows that were fearful versus those that were not fearful of the novel object, Anna was able to demonstrate that those cows that were fearful had less milk yield per milking and longer daily box time in the robotic milking system. And the hypothesis there would be that a more fearful cow would be anticipated to be more likely to, say, kick off teat cup, shift around in the milking box, and be overall just less efficient within that system. And so definitely her personality, in this case, her fear level, may influence her milking behavior and activity. Similarly, she also found an association of fearfulness to a novel human and those cows' milking behavior. In this case, we put a novel human into the arena and look again at whether or not the cow interacts with that novel human. And again, here, a cow that is definitely not that fearful and demonstrating interaction with the person that's standing there. What Anna demonstrated on this front was that those cows that were fearful to the novel human were more likely to be fetched to the robot, less likely to meet their target concentrate allowance at the robot when fed, particularly a higher level there. And as a result of those things, had lesser milk yield and milk fat. And so definitely demonstrating that some of that variation in milking behavior as well as their production could be related to the personality of those cows. And so we're trying to figure out further now how that personality may be influenced in these systems and how we can use that to our advantage to develop individualized feeding strategies for cows kept in robots. The last question that we've been looking at specifically in relation to precision management in robots is, are we able to identify illness earlier in dairy cows? And specifically given the fact that we have a lot of information about the behavior of the cows in the system, as well as ancillary behavioral monitors that are often coupled with these systems that give us a lot of information about those cows and whether or not we can, say, ideally identify cows that may be succumbing to illness earlier on and use that to develop management strategies around that. And so this goes back a couple of years in research already, where we've been looking at this. And this is just one example where my former PhD student, Dr. Megan King, looked at whether or not she could identify cows, say, that were going to be diagnosed with a mastitis event, so an udder infection, based on changes in milk yield as well as the behavior of the cow. And what Megan demonstrated was that those cows could be picked up based on changes in milk yield as well as rumination time or chewing time in those cows almost a week prior to the clinical observation of that disease incidence from occurring. As well, what she demonstrated is that even further back in time, she could demonstrate a difference in those cows' yield as well as rumination from healthy herd mates that those cows have. And what this does is provides this huge opportunity for developing models then that allow us to potentially pick up those cows way earlier and develop intervention strategies for those animals well in advance of what we traditionally would have through visual detection of, say, these diseases. And so the next phase in this research, which we've continued working on, is then developing more advanced models. So using advanced mathematical models, using AI techniques like machine learning to try to develop high accuracy models that are also very precise, that we can use to then potentially do a better job of picking up these cows that are succumbing to illness. So that's a brief summary of some of the areas that we've been working on as it relates to precision feeding and management in dairy cows. The technology that we have available to us in the dairy industry is really what is allowing this to us. And specifically, the move to automated or robotic milking is facilitating a lot of that, and specifically individualized feeding as well as behavioral monitoring opportunities. And this is areas that we're going to continue to work on as we move into the future. Just a thank you to the various funders of the work that I presented here today. Without their contributions, this work wouldn't have been possible. So thank you to all those listed here. And I hope to be able to take questions, so feel free to email me, and I look forward to the discussion that we'll have during the live session on November 26th, and we'll see you then.